back to another episode on your G12 exams. So in this episode we are looking at the 2019 August Science Paper 1. So this is basically physics and it carries 85 marks. So let us move straight to section A, where you're expected to answer 20 multiple choice questions and each question carries 1 mark. And in total, this section has 20 marks out of 85. Let us look at question 1. The diagram below shows 4 identical metal bars placed between 2 wooden blocks on a ruler. What is the diameter of one metal bar? So the question is asking us to find the diameter of one metal bar, and we are told that these 4 are identical bars, so they are basically the same. So we know from here to here is 5, so meaning each one is 1 unit. So we have a 1, 2, 3, then this is 4. If that's the case, then this should be basically 16. So to find the diameter of the 4 identical metal bar is basically 16 minus 4, which is the difference between these two, which gives us basically 12. Now since these are identical, so what it means is when we add the dimension of each individual metal bar, we end up with the sum, which is basically 4d. So to find the diameter of one, we just divide by 4, so diameter is equal to d over 4. So which is 12 divided by 4, which will give us d is equal to basically 3 centimeter. Remember, the units are in centimeter. So if we check from our options, we discover that C is the best answer. Number 2, which of the following would change the period of oscillation of a pendulum? So we have thickness of the string, no. Remember, the 2 factors that affect the period of the pendulums are the length of the pendulum and acceleration due to gravity. And this must be noted that basically the mass of the bulb does not affect the period of the pendulum. So if you check among the options, we discover that C is the best option, because the mass of the pendulum does not affect the period, and also the volume of the pendulum bulb does not affect it. So what you need to understand here is what is period. So period, remember, is basically the time the bulb takes to make one complete movement from A to B, then C, then back to A. So here, then there, then back. So this is the period of the pendulum. Let us move to question 3. The diagram below is a graph showing the movement of a car over a period of 70 seconds. What distance was traveled by the car while its speed was decreasing? So this region, the speed is increasing. Remember, this is speed, then constant, then decreasing. So we have A, which is triangle A, then rectangle B, then we have C. So what we need to find is the area under C when the speed was decreasing. So we know that this is 20. If this is 20, then therefore should be 10, then this should be 30, then this should be 50, then this should be 70. So to find the area under triangle C is half. Remember the area of a triangle, then we multiply by the difference between time, which is 70 minus 60, then multiply by the height from 0 to 20, which is basically 20 minus 0 is 20. So we end up with half multiplied by 70 minus 60 is 10, multiplied by 20. Then this one, 2 into 2 is 1, 2 into 10 is 5. 5 times 20 is 100 meters, since speed in meters per second. So A is the best answer. We move to question 4. The diagram below shows a 200-gram object on a frictionless surface acted upon by 3 forces. Which of the following is correct about the acceleration and direction of movement of the object? So we know this is combined is basically 6. Then this we need to add this to, we end up with 7. So 7 Newton. So we need to find the resultant force. So resultant force we discover is the difference between the pull this direction and the pull in this direction. So since the pull in the right direction is greater than the pull in the left direction, the resultant force will be basically equal to 1 Newton. In which direction? The right direction. So what you notice here is, in this case, the direction of movement, we can eliminate what is not applicable. So A out and D out will remain with B and C. So now we are also required to find acceleration, but we know that force is equal to mass times acceleration. What's the mass? Is 200 grams. Now the mass need to be in kg. So we know that in 1 kg we have 1000 grams. So to convert this to a kg, we divide by basically 1000. So 200 divided by 1000, we are ending up with 0.2 kg. So which in this case we have 0.2 kg times acceleration mass is equal to the resultant force, which is 1 Newton. Then at this point, to find what A is, we just divide by 0.2. Then again this is 0.2. So we end up with 5. So 5 is equal to A. Then what is A? Is acceleration. So it's 5 meters per second square as acceleration. So if you check from there, you see that C is the best answer. Number 5, why would a mechanic prefer to use a longer spanner to loosen a nut than a shorter one? So this one it has to do with the principle of moment. So remember, moment is equal to basically a force times distance. So the longer a spanner from the pivot will increase the moment given a fixed force. So if you look at a longer spanner would add grease to the nut, no, B give a greater turning effect, which is the same as the moment. So basically B is the best answer in this case. We move to question 6. A drum of water of height 2000 Newton is lowered up a plank of length 2 meters onto a platform 0.8 high. What is the work done on the drum against gravity? So remember, work done is given by a force times height or distance. So in this case it's against gravity, so we are using height. So normally we use distance. So now in this case what you notice here is the distance in this case is the height, and this height should always be vertical, not the inclined. Make sure that you remember that principle. So work done will be equal to force times the height. So work done is equal to, what's the force? 2000 Newton. So it's 2000 Newton multiplied by the height in meters, which is 0.8. So multiply that, you're going to end up with a 1600 joules. Remember, work done is measured in joules. So we end up with B being the best answer. Number 7, a crate lifts a 600 kg mass through a vertical height of 12 meters in 18 seconds. So 12 meters in 18 seconds. What is the crane's power output? So power is given by work done divided by time. So similarly, work done in this case is the same as force times height. Now in this case, work done will be now mass times gravity, which is this is a force, this whole thing is force, then we multiply by the height. So the height in this case is 12 meter. Then we need to find this 600 kg, find the force. So the force in this case will be a mass times gravity. So we have mass is 600 kg multiplied by 10 Newton per kg. So what you notice is this kg and this kg cancels. Then when we multiply, we end up with basically 6,000 Newton as the force. Then, having found the force, we can find work done now. In this case, by multiplying 6,000 Newton multiplied by the height. What's the height? 12 meters. So when we multiply this, we are going to end up with basically 72,000 joules as work done. But we are looking for power. So now power, we said, is work done over time, and time should be in seconds, and we have 18 seconds. So power now is equal to 72,000 joules divided by 18 seconds. When we divide that, basically we are going to end up with, remember 18 times 2 is 36, 36 plus 36 is 72. So we have basically 18 to 72 is 4. So we have 4,000, and now power is in watts, 4,000 watts. So 4,000 watts is basically the best answer on question 7. We look at question 8. The diagram below shows a wheel and axle not drawn to scale, used to raise a load of 280 newtons by a force of 40 newton. If the radii of the wheel r and axle small r are 70 centimeter and 5 centimeter respectively, what is the velocity ratio of the wheel and the axle? So what we notice here is the velocity ratio will be basically equal to the distance moved. Remember velocity ratio, so it will be the distance moved by effort. Okay, distance moved by, so now it will be distance moved by the load, what the load moves, then and the effort. Okay, so it's distance moved by the effort over distance moved by the load in this case. So that's what it will be. So if you notice from here, the load is being moved by this wheel inside. You see, wheel's diameter is 5 centimeter. Then the effort is this one outside, whose diameter is basically 70 centimeters. So the ratio is 70 to 5. The effort is 70, then the load is 5. So when we divide that, we are going to end up with 14. So 14 basically is the velocity ratio. So you can also find this by using the principle of basically the circumference moved. Remember, the circumference of a circle is 2 pi r. So divide by, so this is for the effort, the big R effort, then 2 pi small r. So what you notice is this and that will cancel. then you see this radius, this is radius, so this end up with 70 over 5, which will still be 14. So C is the best answer. Let us look at question A9. The diagrams below show a bimetallic strip before and when it was dipped in a liquid of temperature -20 degrees Celsius. So we have before dipping and when dipped. Then the question, which of the following is correct? So option A, metal A is a poor conductor of heat than B. So is this really true? So what you need to look at, can we deduce whether metal A or metal B is a better conductor or worse conductor? The fact that when we dip in cold water, which is in -20 degrees Celsius, these metals are bending, meaning they are conductors of heat. That's why they are able to contract when the temperature reduces. So this is not true. Then B, metal A contracts more than metal B. So which one is contracting more? So metal A is contracting less, that's why it's bending in this direction. So B is contracting more than metal A. So this cannot be true. So this is incorrect based on the fact that metal A is longer than metal B. That's why it's bending in this direction. So B is incorrect and A. Then C, metal B is a better conductor of heat than metal A. We cannot tell from this, just like in the case of hair. Then D, when cooled, metal B contracts more than metal A. This is true because this is pulling in this direction, so it's contracting than metal A. So D is the correct answer. Question A10. A bicycle pump contains 70 centimeter cubic of air at a pressure of 1 atmosphere and a temperature of 7 degrees Celsius. What is the pressure when the air is compressed to 30 centimeter cubic at a temperature of 27 degrees Celsius? So what is the question asking us? Is to find the pressure, which is pressure 2. Given that we have volume 1, which is this one, then we have pressure 1, which is this one, then we have temperature 1, which is this one, then we have temperature 2, which is this one. So how can we answer this question? Then we also have this volume 2. So we can answer this question using the combined gas law, which is the Boyle's law, Charles' law, and the gas law itself. So this one states that we have the product of pressure 1 and volume 1 divided by the temperature 1. So this ratio is the same even for these values. So the ratio of pressure multiplied by volume divided by the temperature in kelvins must equal to the new pressure multiplied by the new volume divided by the temperature, which is now new in kelvins. So pressure is given to us, we know it. Volume, we know it. But where we need to be careful is temperature. Temperature should be in kelvins. So what's the relationship? So temperature in kelvins is given by temperature in degrees Celsius plus 273 degrees Celsius. So let us find temperature 1. It will be 7 degrees Celsius, then plus 273, which will give us 280. Then temperature 2, it will be 27 degrees Celsius plus 273. We are going to get a 300. So these are the temperatures we are going to use. So this is where you need to be very, very careful. If you can remember this, then all is well. Then let us make P2 the subject of the formula here. This is what we are looking for. So pressure 2 is equal to, so we are going to multiply this by that. So we are going to have pressure 1 multiplied by volume 1 multiplied by temperature 2 over, then this one multiplied with this one, so we get temperature 1 multiplied by volume 2. So what do we get? We substitute. So pressure 1 is just this, which is 1, multiplied by volume 1, which is this one, which is 70, then multiplied by what is temperature 2, which is 300, then divide by what is temperature 1. So temperature 1 is 280, then multiplied by what is volume 2, which is 30. This is 30 centimeter cubic. Then at this point you can just start cancelling this and that. 3 into 30, this is 10. Then this and that cancels. Then what we have is 1 times 70 is 70 times 1, which is 70 divided by 28, which is 28 times 1. So when you simplify this, we're going to end up with 7 into 70 is a 10, 7 into 28 is a 4, 4 into 10 is 2.5. So we have 2.5 atmosphere as our pressure, which is B. So this is how you answer this question. So where you need to be careful is converting the temperature to kelvins. If you can do that, you are good to go. We move to question 11. The diagram below represents a position at one particular time on a longitudinal wave. Which positions are one wavelength apart? So again, this is basically a longitudinal. So for us to find the wavelength, we need to find the distance between either two completions, and these are completions. So this is the completion, and this is the completion, and this is the completion. Okay, then this is the point of view here affection. So if we are to find the wavelength, is either we get this from here to here, seen, from this one completion to another completion, or from this point to another point here. Okay, or this point to another point here, not this one. So the corresponding points is here to here or there. So if you see from the options, the wavelength would be basically we have a W and X, not correct, W and Z, not correct, X and Z, not correct, Y and Z. So Y and Z is the best answer. Number 12, which of the following sound frequencies has the highest pitch? So basically, again, here we need to understand what factors affects the pitch, or how does the pitch vary. So basically, higher frequencies produce high pitch, okay, high pitched sound. Then for low frequencies produces a loud or a low sound. So in this case, we need to look for the one with the highest frequency. So the one with the highest frequency will have the highest pitch. So in this case, D is the best option. We move to question 13. The diagram below shows a ray of light from here into a rectangular glass block. Which of the following equation can be used to calculate the refractive index? So refractive index basically is given by the sine. So now what you need to know is basically this is the sine. So this is a simplified version, the sine of angle of incidence, then the sine of angle of reflection. So now this is the medium, in this case a glass, where it's entering, then divided by where it's coming from, the refractive index from where it's coming from. So in this case it's coming from here. So the refractive index of air is basically 1. So once we place this one with 1, then we end up with this one. The refractive index of glass equals basically sine angle of incidence over sine angle of refraction. So to find the angle of reflection, we need to know the angle of incidence. So the angle of incidence is between the incident layer and the normal, so which is basically 1. So we have sine 1 over the angle of reflection is because basically the angle between the normal and the reflected there, which is this one, so which is basically sine 3. So basically that's the case. So if you see from the options, you discover that A is the best answer. We move to question 14. The diagram below shows how an image is formed from an object placed in front of a converging lens. The diagram is drawn to scale. What is the magnification? Okay, what is the magnification? So magnification, we shall call it M, like normally it's called. So it's basically the size of the image. So image size over the object size as the magnification. So we need to look at the size of the object. So this is 1 centimeter, so each one is 1 centimeter. So if you see from here to here, this is 1 centimeter. Then when you come to the size of the image, this is 2 centimeter. So basically we have 2 divided by 1, which is basically 2 times. So 2 times is basically the magnification. Alternatively, you could measure the distance of the object from the optical center of the object from the optical center, then also the distance of the image from the optical center. So if you see from here, we have 1, 2, 3, 4, so 4.5, 4.5. Then from here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So again 4 into 9, which is in this case distance of image from optical center, also distance of object from optical center. So it's to be 9 over 4.5, which is again 2. So those are the 2 options that we can use to find the answer. Question number 15. A negative charged load is held close to but not touching an insulated metal sphere. Which diagram shows the charges that are induced on the sphere? So if you see this is a negative charged, so what will happen is this sphere, okay, is insulated. So we need to know the what is happening in detail. So what is happening in detail? So remember, this sphere has no charge. For now, you can assume that. So once this negative comes charge, what will happen is it is going to attract the positively charged charge close to the negative. Then all the negative will be repelled the other side. So we'll go the other side. Remember the law of the first law of electrostatic states that like charges repel each other, while unlike charges will attract each other. So in this case, this is what is happening. The unlike charge of the negative is a positive. So the positive will move towards negative, then the negative will move away from the negative. So what we end up with in this case is this case that we are seeing in A. We move to question 16. A small heater operates 12 volts, 2 amps. How much energy will it use when it is switched on for 5 minutes? So we need to find heat energy. So we know that energy is equal to basically power used, which is voltage times current, then times time. So this is this part is basically giving us the power used, then multiplied by time, we are going to find the energy. So we are going to have basically voltage is 12, then current is 2, then times for how many? 5 minutes. Now a time should be in basically seconds, because we are finding in joules. So it will be 5 times 60 seconds. So why 60 seconds? Because in a minute there are 60 seconds, so times 5. So we end up with 24 multiplied by 5 multiplied by 60. If you multiply 5 by 24, it will be basically a 120. So this 120 times 60 will give us 6 times 12 is 72. So it's 7,200 joules. So you notice basically D is the correct answer. Number 17, the diagram below shows magnetic field patterns between north and south poles of magnets. Which numbered diagram shows the correct magnetic field pattern? So we have a north and a south. Remember, the magnetic field moves from north to south. We need to know that. So if they're opposite, it will move from north to south. If they are the same, they would pair. That's what should be known. So what you notice here in this case, these are all north. Okay, these are all south. This is supposed to be south because the magnetic field is entering. Then this is incorrect because magnetic field moves from north to south. So the best answer is we look at 4. So 4 is what is correct. So D is the best answer in this case. We look at number 18. A transformer has 1000 turns on the primary core. The voltage applied to the primary core is 230 volts. AC, how many turns are on the secondary core if the output voltage is 46 volts? So again, in this case, we use this formula. So the number of turns in the primary over the voltage in the primary is equal to the number of turns in the secondary over the voltage in the secondary. So the primary has 1000 turns. So we can go on now to simplify this. So we have a 1000 in the primary over what's the voltage in the primary? 230. So 230 volts is equal to the number of turns in the secondary is what the question is asking us to find how many. So you see X over the output. The voltage is 46 volts. So basically we cross multiply at this point. Cross multiply. So we are going to have basically 1000 times 46 is equal to 230x. 230, 230. So that and that cancels. Then this 0 and this 0 cancels. Then 23 into 23 is 1. 23 into 46 is 2. 2 times 100 is basically x is equal to 200. So 200 is the number of turns in the secondary coil, which is A. We look at question 19. What is the purpose of X plates in the cathode ray oscilloscope? So basically this one, remember the X plates are the one that are horizontal. So basically is we notice that is to deflect electron horizontally. Remember this is horizontally. Then vertically is the Y plates. So this one is straightforward, which is B. Number 20, a sodium nucleus decays by emission of a beta particle to form magnesium. Which equation is the correct representation of the decay? So as a sodium has 24 as nucleon number, then proton number is 11. So because the beta particle is basically just an electron, so what is going to happen is basically after emission of this is going to gain an additional electron. So the proton number will increase from basically 11 to about 12. So if you see there, basically we need to have a beta. So this one is a beta particle. So this one is alpha out. This one is a gamma out. This is alpha particle out. So what is going to happen here? This is supposed to be the correct answer, and this is supposed to be basically 12, though you see 11. So we need to look for this beta particle. So option C is the correct on question 20. So basically this is how you answer this section A to get the 20 marks. So please join me as I look at section B and C in the next episode.